Okay, so properties of exponents. Before we get started, let's talk about some vocabulary because you're going to hear me say a lot of things today, and we need to know what I'm talking about. When I say base, I'm talking this big thing right here. Does everybody understand that A is the base, right? And this is the exponent. That small thing up here is called an exponent. Base exponent. We're all good? Okay. So here's our first property of exponents. Oh, let me see. Yeah, so let me have you do this. If you need to take notes, grab a piece of paper. Okay. So the first property of exponents is the zero property. So the zero property says any base raised to the zero power is equal to 1. So we have any base raised to the zero power, there's our base raised to the zero power is equal to 1. Any base raised to the zero power is equal to 1. So what is x to the zero power equal to? Guys, talk to me. What's x to the zero power? If any base raised to the zero power is 1, what's x to the zero power? 1. Very good. Now look inside these parentheses. We have all this stuff raised to the zero power. So isn't any base raised to the zero power 1? So all that stuff raised to the zero power is 1. Do you all understand why x2 and x both become 1? Because they're both raised to the zero power, right? We're all good? So what's smiley face to the zero power? It's 1. You guys gotta talk to me or we're gonna be doing this lesson for hours and hours. Okay, now here's what gets people most times. We have 2x to the zero power. Keep in mind, guys, this is really just 2 times x to the zero power. 2 is not connected to x to the zero power by anything other than multiplication. So really, 2 is raised to the first power. There's no parentheses saying 2 is raised to the zero power. Do you see the difference between this one and this one? So 2 is not raised to the zero power. Just x is raised to the zero power. So any base to the zero power becomes a 1. So just this piece becomes a 1. So really we have 2 to the first times 1. Do you all understand that? Just x to the zero power became a 1. So we have 2 times 1, which is 2, right? Does everybody see the difference between these two? Okay. Here's a common mistake. People will say any base raised to the zero power is 1. So I'm going to show you a common mistake. So they'll say, okay, any base raised to the zero power is 1. So they'll say the base rate is 1. The exponent doesn't become 1. The whole thing becomes 1. So it's not a to the 1, the whole thing became 1. Does that make sense, everybody? Okay, sweet. Here we go. Next property, negative exponents. And we'll really just use this in our final answers. We've got to look at our final answers and say, do we have any negative exponents? If so, that's not simplified, so we're going to simplify it. So when you have a negative exponent, you must flip it over a fraction, and that will make it a positive exponent. So if we have base a raised to the negative n power, that would not be simplified. So we draw our line, and we would take that and flip it over a fraction. Do you see how that came down here? We flipped it over a fraction, and now it's a positive exponent. Does everybody see how that works? Now left on top was a 1, because you can't say, even though we grabbed a raised to the negative n and pulled it to the bottom, it doesn't just leave nothing on top, there's always technically a 1 left on top. That makes sense, everybody? If not, you gotta tell me, because I don't know if I'm making sense. Okay, so we have x raised to the negative 2 power. We have a negative exponent, not acceptable. So we need to flip it over a fraction. So I draw my line, grab it, flip it over a fraction. It's on bottom, and now it's a positive exponent. What was left on top? 1. So we have 1 over x squared. Do we have questions? So let's do a to the negative 4. Same idea, right? We draw our line, grab it, flip it over a fraction. Left on top was a 1. On bottom, we have a to the positive 4. Common mistake I see is people will flip it over a fraction and then write a negative exponent on accident, but the whole point of flipping it was to make it positive. All right, next example here. I'm looking at this example. We have 3 over x to the negative 2. 3 does not have a negative exponent, right? 3 to the positive 1. But on bottom here, don't we have x to the negative 2? So to fix that, we take it, we flip it over the fraction. So now we're going to flip it up to the top. You see why? Because it was on bottom with a negative. We're flipping it over a fraction. So we have 3 on top, and now we have x to the positive 2, right? Everybody? And on bottom we have a 1, which anything divided by 1 is just itself, right? So we have 3x squared. Does everybody understand that? Okay, looking at this one, we have 1 over b to the negative 3. We have a negative exponent. We're going to grab it, flip it over a fraction. So that will be b to the positive 3. Questions? Next property. So I was just gonna throw some caution at you. Remember that 2x to the negative 2, this 2 part is not raised to the negative 2. What I see people do is they'll pull the 2 down with that x to the negative 2, but that is not correct. 2 is not raised to the negative 2. 2 is raised to the positive 1, so we leave the 2 there. We only flip this piece over the fraction. So 2 would stay on top, x squared is on bottom. So same thing here, right? 3 is not raised to the negative 4, right? So we would only flip this piece over a fraction. All right, so looking at this one, a lot of people say, oh, 3 and x to the negative 2, we've got to take that whole thing and flip it over the fraction, but that's wrong. Because this is really just 3 times x to the negative 2. So only this piece has a negative exponent. We would only flip that piece over the fraction. We'd leave the 3 on bottom. So on top we have a 1. And now we have x to the positive 2. Flipped it over a fraction to make it a positive exponent. On bottom of 3. Are we all comfortable with that? We wouldn't even need to write that 1 there. 1 times anything's just itself. So just making a point. On top we have x squared. On bottom we have a 3. 1 times x squared is just x squared. Comfortable? Going too fast? We're all good? Okay, we're almost there, and then we'll do some practice problems, okay? The multiplication property. When you multiply the exact same base, then you need to add the exponents. And I'm going to have, this is where my song begins, and it starts out, when you multiply, you add. Now understand, that's only if you have the same base, and you add the exponents. Do you see how we have a times a? We're multiplying the same base, so we add our exponents. So we would combine this, we're taking this, squishing it together, using properties of exponents. So we'd add our exponents. So we have, looking at my first example, x squared times x cubed. When you multiply, you add the exponents. So we would have x to the 2 plus 3, which is x to the 5th, right? Everybody? And why does that work? Because we know x squared is x times x cubed is 1, 2, 3. How many x's are there? 5. You see how we got x to the 5th? Okay, let's do this one. Next example, a little teeny bit harder. We have x to the negative 1 times x to the 3rd times x. What is the exponent on x here? Don't say 0. What is it really? 1. Very good, right? If there's nothing there, it goes without being said it's a 1. We're multiplying the same base, so don't we add our exponents? So we have x to the negative 1 plus 3 plus 1. So that becomes x to the 3rd. Questions? Okay. So let's do some examples here of that. This top one, x squared times a squared. When you multiply, you add. Do we have the same base here we're multiplying? Nope. So can we add the exponents? No. You all understand how x and a are different bases. So our answer would just be the same thing. X squared, a squared. We can't combine those. They do not have the same base. All right, next one. We have 2x cubed times 3x to the negative 2. Now, pay attention to what I'm about to say. A lot of people think that 2 and x cubed are connected, and they think that 3 times x to the negative 2 are connected, and they're not. This is really just a multiplication sign in here. So it's just all this stuff being multiplied. So we can reorder this in any order. There's no connection. We can re-put it in any order. So I'm going to put like bases by each other, or like variables by each other. So I'm going to reorder it. We have a 2 times 3. I'm just reordering it. We have an x cubed. And we have an x to the negative 2. You see how I just reordered it? They write it like this to see if you know that those aren't connected. Does that make sense? It kind of looks like they're connected. So now let's simplify. Now the song goes, when you multiply, you add. That's not true for numbers. We know that 3 times 2 or 2 times 3 is not addition, right? Those are on the same base. Well, the song only works for exponents. So what is 2 times 3? 6, right? And when you multiply the same base, you add your exponents. So 3 plus negative 2 is 1. So 6x to the first. Questions? Okay, next one. Here we go. So we are going to they want us to get confused and think that 4 is connected to a squared and negative 3 is connected to a and 2 is connected to a to the negative 2, but it's not. It's just multiplication here. So let's reorder it carefully. So let's reorder it. We have a negative 4 times negative 3. You see I'm crossing them out so I don't miss anything, times 2. Do we all understand how we can reorder it? I can't tell because you're not saying much. So then we have a squared. We have an a to the what? 0? 1. Good. And then we have a to the negative 2. And those are all being multiplied, just in a different order. So let's multiply that out. If you have a calculator, you could just use that. Negative 4 times negative 3 is 12. 12 times 2 is 24, right? We have 24. When you multiply, you add. So we're going to add these up, and we get a to the first. 2 plus 1 minus 2 is 1. So we have a to the first. Questions? 24, a to the first. Okay. We've got it then. Okay, number 4 on your worksheet. Let's do it together. Here we go. Number 4 on your worksheet. 3ab cubed times 4a to the negative 3, b to the negative 2. So we have a bunch of things here. Aren't they just all being multiplied? Yeah. Let's reorder it then. 3 times 4 times a to the first. I want you to write those in so we're really good at it. It's not the same. Number 4, is it? Let's see, what did I do? That is really weird. Just a second. Okay, so this is not number 4. You'll be able to practice your number 4. So just quickly watch. So I'm reordering it. We have a to the first, a to the negative 3, putting that b cubed, b to the negative 2. I reordered it so my like bases are by each other. So now we can simplify it. That is 12, right? When you multiply numbers, you multiply the numbers. When you multiply, you add. So we have a to the 1 minus 3, right? 1 plus negative 3, which is negative 2. And then we're adding up 3 plus negative 2, which is 1, right? Now, is this answer acceptable? No, we have a negative exponent. So we're going to flip the piece with the negative exponent over a fraction. Come on. We draw our line, 12. We are not going to flip that. Oh, we've got to flip that. We're going to flip that? No. So left on top, we have a 12. We have a b to the first, which is b. And on bottom, we have a to the positive 2 now, right? We flipped it over a fraction. We're all comfortable? Okay. One last one, then I'm going to let you practice. Here we go. Multiplication. So none of this is connected, even though it kind of looks like it. It's just connected by multiplication. So we can reorder it. Negative 2 times negative 3. X to the 0, which is 1. So I have times 1. And then we have an x to the negative 2. Then we have a y to the negative 3. And then we have a y to the first. Now let's simplify it in sections. Negative 2 times negative 3 times 1 is negative 6, yeah? No, positive 6, right? Positive 6. X to the negative 2, there's no other x's, so x to the negative 2, we've taken care of that. When you multiply, you add. Negative 3 plus 1 is negative 2, right? So now we've got to write our final answer with no negative exponents. So we only flip the parts that have negative exponents. 6 is not a negative, doesn't have a negative exponent. That's 6 to the positive 1. We'll flip that down. Oh, we've got to flip that down. So on top we have a 6. On bottom we have x squared y squared. Now those exponents are positive. We're all comfortable with that. You've seen this from last year. Okay. So 1 through 10, show me that you got it. Or to learn again. So we're now going to talk about, we just did the multiplication property, now we're going to do the quotient property. So the first of our song says, when you multiply, you add. Then the second part of the song says, when you divide, then you subtract. So if you have the same base being divided, you subtract the exponents. So division is subtract. When you divide, then you subtract. Here is the key thing to remember and the most important. You always subtract the top exponent from the bottom. Do you see how I did the top one n minus the bottom n? Very important. No matter what, this rule is always the same. You take the top minus the bottom. Okay, so when you multiply, you add. When you divide, then you subtract. So let's do this one. A to the 5th divided by a cubed. So we're dividing the same base, so we subtract our exponents, the top from the bottom. So this is a to the 5 minus 3, right? Guys? This is a squared. Does everybody understand? Yes? Okay. Now, you could check that because really what we're doing here, a to the 5th means we have 5 a's on top, and I don't want you doing it like this because this is just a way to check your answers. 1, 2, 3, 4. We have 5 a's on top, a to the 5th, and we have 1, 2, 3 a's on bottom. So if you look and divide out those a's, we have a times a left on top, which is a squared. Does that make sense of why that works? So looking at this one, a to the negative 2 divided by a cubed. The bases are the same, so you subtract the exponents. You subtract the top from the bottom. So aren't we going to be doing negative 2 minus 3, the bottom? Divide, then you subtract. Yes or no? Okay, so we have a to the negative 2 minus 3, which is negative 5. Is that answer acceptable? No, right? We flip it over a fraction. So we have 1 over a to the positive 5. Does everybody understand? When you divide, then you subtract. Okay, so some more examples. Like I said, sorry about that. I thought that your worksheet was the same as mine, so let's just look right here really quick. So we're simplifying this. The numbers you don't subtract. Numbers division is division. So 2 over 2 simplifies to be 1 over 1, right? 2 divided by 2 is 1. Now we have y on top. Do we have a y on bottom? Yes. So what is the exponent on this y on top? 1. So we have y to the 1st on top, and on bottom we have x to the negative 4, y to the 3rd. When you divide, then you subtract. So we're going to look at our same base, y to the 1st, and we're going to subtract the bottom exponent, which is 3, right? So on top, we have y to the, what's 1 minus 3? Negative 2, yeah? And then we still have this x to the negative 4 on bottom. Now there's our answer, except for we would say, is that answer acceptable? Nope. We would flip any negative exponents over a fraction. It looks like we need to take this one, flip it over a fraction, and we also need to take this one, flip it over a fraction, because aren't those both negative exponents? So when we take that y to the negative 2 and we put it on bottom, it'll be y to the positive 2. And on top, we take that x to the negative 4th power, we put it on top, it'll be x to the positive 4th. Now you can't do anything with an x and a y, they're not the same base. Questions? Yes.
Or if two bases are different numbers.
Like if we have 9 over 3?
No, like 2 over 3.
Like 2 over 3? We would say, do those numbers simplify? Nope, 2/3 is the most simplified it gets. Nothing goes into 2 and 3. You leave it. 2 on top, 3 on bottom. Good question. Okay, next one. Here we go. 6x to the negative 2, y squared. Everybody watch. We're going to simplify it in sections. 6 divided by 3. That does simplify. Don't they both divide by 3? 6 and 3? So 6 divides by 3 and becomes a 2, right? Should I not write in that green? Kind of hideous. I mean, it's kind of like hard on your eyes. Do you guys understand what I'm saying? 6 divides by 3 and becomes 2, right? I do this for a reason. 3 divides by 3 and becomes a 1. So they both divided by 3. I do that so I don't misplace and put the 2 in the wrong spot, because sometimes the 2 will be on bottom, just depending if 6 and 3 were flipped. So I always write it like this. When you divide the same base, you subtract the exponent. You always subtract the top from the bottom. Now watch very carefully. We take our top exponent minus the bottom exponent. What is our bottom exponent? -1. Minus -1. You see why I did minus -1? That's where most people mess it up. So I'm going to cross off that x because I took care of it. Then we have y squared, and we're going to subtract. When you divide, you subtract. This is a 1. So it'll be 2 minus 1. So on top, we have a 2. We have x to the what's -2 minus -1. Now, when you minus a negative, it becomes positive, right? So -2 plus 1 is -1. And then we have y to the 1. Now we look at it and say, yeah, that's our answer. However, is it acceptable? No. We've got to flip our negative base, our negative exponent, we've got to flip our base over the fraction. We'll take that, pull it down, just that, x to the +1. So our final answer will be 2y, y to the first is y, and then x to the first is x. That would be our final answer right there. We're all comfortable? I can't tell. If you need help, let me know. Okay, next one. 3x squared y to the -4 divided by 6x cubed y to the 5th. When you divide, then you subtract, but not with numbers. So 3 over 6, don't they both divide by 3? This is where people mess up. This becomes a 1, this becomes a 2. So isn't 2 on bottom? Yes. So we're going to be doing the divide, you subtract. So it'll be 2 minus, now look at the bottom is 3, right? You see what I'm doing here? We have -4 minus 5. Okay, so on top we have a 1 times x to the 2 minus 3 is -1. Y to the -4 minus 5. Isn't that -9, guys? And on bottom, we have a 2 left, and that's it for right now, right? You rewrote it? You get what I'm doing? I can't tell. Okay. So now we'll simplify it. Oh, we need to flip that. We need to flip that over a fraction. Left on top was a 1. On bottom, there was a 2. Now there's an x to the +1. Now there's a y to the +9. This answer is great. Okay, we're all good. You're ready to practice. Okay, do 11 through 20.